to Bry-Air. As I mentioned earlier, I came from cell manufacturing, so I've learned quite a bit in the 6 months or so that I've been in the dry room space. This is a 101 course. I'm not a civil engineer, so I'll do my best to field all the questions I can. At the very worst case, if I can't answer them, I'll be sure to get back to you after the talk. So the structure of this conversation, first we're going to look at why battery manufacturers need dry rooms in the first place. It's a fairly unique aspect of cell manufacturing that you need such low, ultra low dew point conditions to make lithium ion and sodium ion cells. Then we'll dive into how moisture levels are measured and how dry rooms actually work. What are the mechanics behind the removal of moisture from a controlled space, ensuring dew points as low as -40°C and even lower for solid state technologies. What factors influence dry room design? These are the conversations I get into with customers as they're looking to build out dry room space for their battery manufacturing facility. And then finally, are dry rooms needed for battery technologies of the future? Spoiler alert, yes, they are. We'll talk a bit about future technologies like solid state that are becoming more and more prevalent and how dry rooms are used in their production. So why do battery manufacturers need dry rooms? In a nutshell, it's because batteries contain hygroscopic materials. Things like lithium and sodium have a very strong affinity for even trace amounts of moisture. You can see that chemical reaction there. Essentially, what that's saying is lithium in the presence of water will form lithium hydroxide and hydrogen gas. Now, what this results in practice is certain issues with the cell, like cell swelling, decreased cycle life, reduced energy storage capacity. So, in a market where maximizing cell performance, maximizing cycle life, and energy storage is absolutely critical, you really don't want uncontrolled environmental conditions to be the cause of less than optimal cells. It's oftentimes that when you have an issue in production, you go about diagnosing the production equipment, what could be going wrong, and an often overlooked facet of cell manufacturing is just the ambient conditions within the dry space need to be dialed in just right to make sure that you don't have certain cell defects. How are moisture levels measured? So we will touch on two different units of measure or two different measures of moisture level, starting with a definition of each. First, you have dew points. The formal definition is the dew point is the temperature at which water vapor begins to condense at a given state of humidity and pressure as temperature is being reduced. Now, dew point relative to relative humidity is typically a better standard of measurement because it indicates absolute moisture in the air. Relative humidity, on the other hand, is relative. It's relative to temperature. So if you don't know the temperature in the space and you have a relative humidity value, you don't really understand what the absolute moisture is, which is what needs to be controlled. The definition of relative humidity is essentially the amount of water vapor in air as a percentage of the amount of water vapor in saturated air at the same temperature and pressure. So you can imagine if you have a very large dry room with temperature fluctuations throughout the space, you could have a consistent 1% RH throughout the facility. And if there's varying temperatures, what that means is there really are variances in moisture levels, which is what we're ultimately concerned about. There are various ways to measure moisture. One that I've mentioned here is a capacitive humidity sensor. Essentially, it uses a polymer which will absorb moisture from the air, which causes a capacitive change across the sensor. That change in electrical capacitance can be measured, and moisture can be quantified through that change. I'll take a pause there. Any questions or comments or anything you want to dive more deeply into before I get into the actual mechanics of dry rooms? If not, I will chug right along. So, how do dry rooms work? Um, First off, dry rooms they're maintained at positive pressure relative to the outside environment. So this is essentially a safeguard to reduce moisture ingress and the introduction of contaminants. You're not going to be able to fully eliminate moisture ingress just by maintaining a positive pressure. Moisture can actually travel against the pressure gradient to some extent, but it certainly has some effects in maintaining low moisture levels. These rooms do need to be connected to desiccant dehumidification units, or DHUs for short. That's what you see in that image right there. That's what we at Bry-Air manufacture. Essentially, these units use a desiccant media like a silica gel that readily adsorb moisture. They have a high adsorption capacity. It takes that moisture from the controlled space and expels it to the outside environment in a separate airstream. So, what that means in practice is these DHUs will continuously pull in intake air from the outside environment. That air is sent through a desiccant wheel, which contains that silica gel or that high adsorption capacity desiccant. That desiccant will remove the moisture from the air. Once it's removed a certain amount of moisture from the air, it will be rotated into a different airstream where hot air will drive off that moisture and expel it to the outside environment. That desiccant, which is now dry, needs to be cooled back down to regain its adsorption capacity and then brought back into that original airstream where it could continue to remove moisture from the intake air. So in practice, what the result of that is incredibly dry, -40, -50, -70 degrees Celsius air being pumped into the dry room continuously to maintain very dry conditions. The factors that influence dry room design. So many people think that the most important factor that affects equipment sizing and ultimately costs of a project is the size of the room itself. Now, while the size of the room obviously does have some impact on cost, really one of the most important factors is moisture load. That's essentially the amount of moisture that's being introduced to the space through things like people, door openings, process equipment exhaust. Really, it's that moisture load that's going to drive equipment sizing, equipment selection, really, which is the major cost driver to a project. Sensible heat, which primarily comes from process equipment, also has to be taken into account when sizing equipment. There's obviously quite a bit more that goes into dry room design than what's just being shown on this slide. This is really meant just to be a very high level overview. When we work with our customers to define dry room specifications, we go through everything from airlock design to considering the moisture ingress through epoxy coated floors. All of that has to be taken into account when you're dealing with such low dew points. Then are dry rooms needed for battery technologies of the future? Yes, absolutely. So today, lithium ion batteries in general, they typically need to be handled in environments at about -40 dew point. What we're seeing with solid state batteries, especially solid state batteries with sulfide based electrolytes that tend to hydrolyze very readily in the presence of moisture, they need to be maintained as low as -100 degrees F. This is obviously very low dew point. It's made even more challenging to maintain such a low dew point when you introduce considerable moisture load. So that's the way that a manufacturer could handle that is through state-of-the-art DHUs, and then by upsizing their equipment to ensure that you are removing as much moisture as possible. So in short, dry rooms aren't going anywhere. They will be needed not only for lithium ion battery production, but solid state battery production. Essentially, wherever you have lithium or sodium or any hygroscopic material that reacts very readily with even trace amounts of moisture. And then finally, I've got to do my shameless plug for Bry-Air. We're based out of Sunbury, Ohio. We've manufactured desiccant dehumidification equipment for over 60 years now, and we've had a lot of success in the battery space by offering turnkey battery dry rooms, primarily for small and medium-sized rooms for R&D facilities, universities. Battery manufacturers kind of operating at the small to medium scale. That's where we've seen a lot of success in offering a one-stop shop, sole point of accountability for these people looking to commission dry rooms on a relatively quick timeline. As I mentioned before, we're based out of Sunbury, Ohio. That's where all of our engineering is. One of our mantras is we provide a stress-free experience for the customer. That means all of your engineering support it's readily available. We've got a network of service technicians across North America that do service and maintenance on all of our units. That is really the crux of the presentation. I kind of rushed through it a bit more, so we did get a late start, but I wanted to leave plenty of time for some back and forth. If you have any questions or comments on dry rooms, would certainly love to go through those at this time. I see a couple of familiar faces in the audience. Anthony, I hate to call you out, but I got to call somebody out.
That's fine.
I,
I was busy looking for the unmute button.
I appreciate you listening in. I know Anthony Sedano with the Sedano Consulting. He's got a lot more experience in dry rooms than I do. So I figure I don't know. Is there anything that jumped out to you, Anthony, that you
I
think?
was, yeah, nice presentation. Well, I'm interested to understand when you talk about small and medium sizes, what's your s- sweet spot or how big you can go in dry rooms?
For sure. So really the one of the larger dry rooms that Bry-Air has installed was actually at my former employer at IM3. That was a 55,000 square foot room. Again, as I was saying before, the equipment sizing is not really driven by the size of the space, but it more so the moisture load. But that facility, it's a full-blown production facility. So you've got a lot of people coming in and out of the room, a lot of operators in each portion of the facility. So it is a sizable facility. There are 4 DHUs across 2 separate dry rooms in that space. So that's by no means the upper limit of what we can achieve, but I'd say that's kind of in our sweet spot. We go as low as certain universities, for instance, they just want a very small space to do kind of bench tests, things like that. Small 10 by 10 9,000 CFM DHU. That's not uncommon for us as well.
And when you get into those larger sizes, what would you say are differences in design or um, equipment, any philosophical design changes or differences between, a small university lab dry room
For
versus
sure.
something that large?
Yeah.
I mean, yeah.
Absolutely. So, I mean, at a high level, there absolutely are design differences. I may not be the best person to elaborate on all of those design differences. It's a bit outside my wheelhouse, but just the sheer number of DHUs that are required for some of these larger gigafactories is astounding. We've seen certain jobs that we haven't done ourselves, but there are requests for bids out for these massive gigafactories that have well over 110 DHUs across various dry rooms. So obviously integrating all of that into a room is quite an engineering feat. And I'm sure there's a lot of nuance behind the design that is above my pay grade. But it's they're 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 there's a lot that goes into the large gigafactory constructions.
Great. Thank you.
I have a question. Hi, Haley Hartenbauer with Mortensen Construction. So familiar with your products and services, but kind of curious if you could elaborate on the misconception between a dry room and a clean room and what some of the differences would be.
Absolutely. So you see, that's a great question, by the way. You see clean rooms in across a lot of industries, from pharmaceuticals to medical device companies. And really the key focus in clean rooms is maintaining certain cleanliness levels, kind of delineated by ISO standards. Just making sure that outside particles don't enter the controlled space. Oftentimes, clean rooms will have humidity controls in place, but it's nowhere near the level of the extreme level of dryness that is achieved in a dry room. Take semiconductors, for instance. Typically, they're maintained anywhere between 20 to 45% RH, but cleanliness is hugely important. So they've got their own kind of safeguards in place to ensure a clean environment. Contrast that with battery manufacturing, where you need to maintain in RH, you're less than 1%. So while the construction of the room itself is very similar, you've got similar panels and it's a more or less sealed environment. You need to have dedicated desiccant dehumidification equipment to remove even higher levels of moisture. Now, I would say in battery production, cleanliness is also very important. Oftentimes, battery manufacturers will specify a certain ISO standard on their drawings to make sure that foreign particles aren't introduced into the system. So you do need to take that into account when determining number of air changes per hour in that dry room. So in that regard, there is a bit of crossover. Like I would say a dry room is, and this might be an ignorant statement, but a dry room is a more specialized version of a clean room, if that makes sense.
Yeah, no, I appreciate that. I think there seems to be a lot of discussion out there where people are specifying ISO levels when really it's the dry room that should come first, and the particle count really is secondary to that. Which
For
when you're
sure.
selecting equipment for building design, that can make a big difference one way or the other.
Yeah, absolutely. And one way, I mean, in a dry room, when you have those ISO call outs, one way that you achieve that is just by increasing the air changes that from the DHU. So there is definitely some interplay there that needs to be taken into account.
If I can chime in, I mean, it's kind of like a combination of the two for different reasons. The
Mhm.
dryness is for, um, you know, stopping reactions, as Keith pointed to earlier. You know, some materials are hygroscopic and absorb moisture and leads to, poor performing batteries. So there's, the dryness level affects the materials. The cleanliness level affects particles that can get trapped within the cell and lead to shorts and so on. So it's
Mhm.
kind of different failure mechanism of the cell. And so they usually specify both. But like it or not, it's kind of a combination of the two. And as Keith mentioned, you can address each one independently, but like it or not, it boils down to movement of air, whether you're
Mhm.
drying it or filtering it to clean it. So they kind of overlap.
Yeah, absolutely. Thanks, Anthony. Now, Haley, you mentioned you were with Mortensen. Have you guys done any dry room installations?
Not specifically dry room,
Mhm.
more in the semiconductor where you're looking at the ISO. And again, we toured several battery facilities where
Mhm.
um, the clean room protocol isn't necessarily followed to enter into the dry
Yeah.
space, even though it is a classified room. So we've coming from the semiconductor industry, and that can be a little confusing,
Mhm.
where it's a classified room, but yet the same gowning requirements aren't part of the
Yeah.
standard operating procedures.
Yeah, that's interesting, and I've seen that myself, and I don't know if that's a function of the battery manufacturing industry being a somewhat nascent industry in the United States, that we haven't adopted the same level of not PPE, but like gowning requirements as maybe we should have. I've been in a lot of battery facilities where you don't even have to wear masks or suits or anything. You put on safety goggles and that's it. Which I'm fairly confident if you go to these large gigafactories that have been in operation for decades, you're definitely gowning up and you're wearing a mask and you're covered head to toe. So it's, yeah, it's interesting kind of the discrepancy you see across the industry.
think there's a better understanding of the effect of moisture on a cell than the
Mhm.
effect of cleanliness. Also, there are several of the manufacturing processes which are, like it or not, dust producers, whether it's mixing
Mhm.
of powders or cutting of electrodes and creating dust within the process, which is not the case in semiconductors. So it's sometimes a little bit of an oxymoron. You're trying to keep an environment clean, but you've got a kind of particle producing process as part of it.
Mhm. Yeah, absolutely, and it gets dirty quickly if you're not careful about it. So mixing rooms, if you're not maintaining those mixers and you don't have proper protocol, it's a mess. Excellent. Well, again, really, I appreciate your time today. If any questions come up after we get off this call, please do reach out to me. My contact information is there. Happy to connect on LinkedIn or wherever else. We're eager to support. If you have any upcoming dry room projects, we would love to get a chance to discuss and help you work through your designs and get a dry room commissioned. So yeah, thank you all very much, and I hope to be in touch soon.